Now we are ready for 9-6 dilations. Dilations. So we've talked about dilations before in earlier chapters, and this is, dilations means we're going to make it bigger or smaller. Make it bigger or smaller. Also known as scale, scaling an object, making it bigger or smaller. Alright, so here's an example. So I might have a triangle that looks like this, and this is triangle LMP, and we'll have a center of dilation right here, and we're going to draw a line that goes from our center here of dilation, and it'll go through each of these points. Alright, and we'll just say from here, from this center of dilation to P is 4. And then we're going to dilate this thing so that P prime is, the distance from here to P prime is 10. Alright, so then we would take that same distance, or the same, not the exact same distance, but the same proportion of 4 over 10, and we would attribute that to this m to make this distance from this point to m 10 bigger, so that would make the m be over here, m prime, and from this point to L needs to be 10 bigger, and so that's going to be about right here, L prime. And so now we have dilated LMP, triangle LMP, and so this would be the image, and this was the pre-image. Now these shapes should look exactly the same, except for one is bigger and one is smaller, but they're the same shape. Now we're talking about this 4/10 stuff, and what I'm talking about there is the scale factor. So the scale factor is, as you hopefully remember, we talk about it as K. Usually we call the scale factor K, and we say we put the image over the pre-image. And that's how we get the scale factor. Pre-image over the image. So in this particular case here, we've got 10 divided by 4, which is 2.5. 2.5 is my scale factor. And this is an enlargement. It went from small to big, so it's an enlargement. If K is greater than 1, then you have an enlargement. Okay. Now, a reduction is when K is less than 1. So I'm going to write reduction over here. And that's when K is less than 1. And let's look at what some of these might look like. So here are some examples. And I would like to use rulers for this, but I'm just going to assume that you don't really have access to a ruler right now. And so we're just gonna label everything clearly. So we're going to do a reduction. We're going to do K equals 1/2 right here for this example that we're about to do. And so we're going to draw a triangle that looks like this, and we'll say that this is about 1 inch. Not hypotenuse, because we don't know if this is 90 degrees, right? So this longest side here is 1 inch. Now we're going to draw a point back here that's, we'll say this is 1 inch away. This is probably bigger than 1 inch, but we'll say 1 inch here. And this is D. This is our point of dilation. And so if this is 1 inch away, so if this is 1 inch away, then I want a reduction of 1/2, then I just say 1/2 an inch. Here we go. This is triangle ABC. So I go 1/2 from B to D, half of the distance, and so that'll give me B prime. And then if I go from D to A, and I go half of the distance from D to A, would be right about right here. This would be better with a ruler, right? And so that is where A prime is going to be. And then D to C, half of the distance is going to be right about right here. That'll give me C prime. And then I connect these dots and shade that in. And so if this side was 1 inch, then this side should be half an inch. And we can see that each of these distances here are half the distance. The image and the image here and the pre-image. The pre-image is this size, and the image is half the size of the pre-image. Now, that is a reduction. Notice the pre-image is larger than the image. We reduced it by half. And we used the distance from the point of dilation to scale this thing. And that's probably the easiest way to do this. Let's do an enlargement. So this was in a reduction. Let's do an enlargement, k equals 2. All right. So let's start over here. Let's draw a point here, and then we're going to draw a dotted line that goes along like this, and we're going to draw one that goes along like this to help us put our triangles here. So I'm going to put a triangle right here. And this is triangle ABC. And so I want to do an enlargement of 2. So my scale factor is 2. So what I want to do is, here is 1, the distance. I'm going to look at A first. So this distance, I need to multiply that distance by 2 to get where A prime is going to be. And that looks like it's going to be right here where this C is. That looks like about that right distance. So there's A prime. And now this distance of C, I want to double that to get to C prime. So that's going to be over here, C prime. And then I'm going to have this distance from this point here to B. Do that again, so it's twice that, B prime. And now I draw my shape. My triangle, there it is, pre-image, image. I have an enlargement of 2. All I did was I doubled the distance between my point of dilation and my pre-image points, and then connected those dots, and I have my enlargement there of my my pre-image and my image. It's all labeled, looks good. So I would like to say any questions, but we ought to just keep going. Oh no, running out of batteries. All right, let's do some more examples. So here's an example where we are going to say, is this an enlargement or reduction. And what is the K value? Right, so let's start with this shape. It is a parallelogram, and J is going to be our point of dilation, and then we're going to draw some lines out from each one of these points, and then we're going to say here we're going to put a point right here, and this is, and then we're going to follow the shape of the parallelogram like this. And from here to here is 2, and from here, from J to the image is 3. And this is the image, and this is the pre-image. So we have to decide, is this an enlargement or a reduction? So the image is larger than the pre-image, so therefore it is an enlargement. And what is the K value here? So the pre-image from J to here is 2, and the pre-image goes on the bottom or the top? The bottom. Thank you, the bottom. And the image, the distance from J to the image here is 3. So your dilation, your scale factor, K, is 3 over 2, or 1.5. Alright, let's do another one. Let's do it right down here. So for this one, I'm going to draw a 90-degree angle here with 2 rays coming off. I'm going to draw a little guy that looks kind of like a trapezoid, and this is going to be called Q. And then I'm going to draw a big guy that looks like the same trapezoid but bigger. And this is Q prime. And this point here is point C. From C to this vertex here is 5. And from here to here is 15. So what is the scale factor of this situation here? So first we have to decide which one is the image and which one is the pre-image. So I know this one is the image because it has the little prime sign here, and this one would be the pre-image then. So to find my scale factor, I say K equals 15 is the image, the value of the distance here from C to the image, and then 5 is the distance from C to that same point on the pre-image. So 15 divided by 3, my scale factor, 15 divided by 5 is 3, my scale factor is 3. So this was determine the scale factor, is what we did here. Alright, and that is what we're doing with dilations on this regular piece of paper. Hopefully in your packet you received a piece of paper that looks like this, and it's got it's got a whole side here that's empty, so that we can do some dilations here. We're going to do these same dilations here, but we're going to do them again right here. All right, so let's do some dilations in the coordinate plane here. So we're going to continue with 9-6, and these are dilations in the coordinate plane. And we're going to do those. All right, for reals this time, here we go. We're going to start with an example. And so this example is, we're going to start with A is 2, 1, B is 0, 3, C is negative 1, 2, and D is 0, 1. All right, so let's plot these points here. So A is 2, 1, and that's A. B is 0, 3, that's B. C is negative 1, 2, that's C. And then D is 0, 1. Alright, so we have this kind of funky little shape. So that is our pre-image, that's where we're starting. And then we're going to do a scale factor of 2. So I've got my A, B, C, and D. Prime. Alright, now my center of dilation here is the origin. So all of these we're going to be doing the origin as our center of dilation. So that makes it so so that we can do something that's very easy in one sense of the word, and that is that all I do to if the origin is my center of dilation, all I have to do to find my image points is to multiply each value x and y for each point by my scale factor. So I just say 2 times 2 is 4, 2 times 1 is 2. So A prime is going to be 4, 2. Let's just do all of these points and then we'll plot them. 0 times 2 is 0. 2 times 3 is 6. And for C, negative 1 times 2 is negative 2. 2 times 2 is 4. And then 0 times 2 is 0. And 1 times 2 is 2. So those are all my points. So now let's plot them. 4, 2 is my new A value. So 4, 2, A prime. And then B is 0, 6, 0, 6. B prime, and C is negative 2, 4, negative 2, 4, C prime, and then D prime is going to be 0, 2, right here, D prime. Now I just connect these guys. And shade that in as my image. And that's all there is to it. Now let's have you guys do one on your own. So just follow the same, follow this example. Oh, did I have not those things there the whole time? Sorry. Here's all the points that you can fill in for this bummer. Okay, Q is going to be 0, 6. And R is -6, -3. S is 6, -3. My scale factor is 1/3. All right, so this is a U-try. And I'll try to give you a little explanation first, and then you guys do it, okay? So remember what we did over here is I took each of these points, the X and the Y value, and multiplied it by 2 to get my new point for my image. So I started with the pre-image, so we're going to start with the pre-image here, QRS. And so let's plot that real quick. 0, 6, which is Q, -6, -3, -6, -3, R, and S, 6, -3, QRS. Right, so I have this huge triangle here, and in order to do my dilation, I multiply, as I did on this first one, each value X and Y by 1/3 to get my new image. Now, is this going to be a reduction or an enlargement? Reduction! How do you know that? Because it's less than 1! Excellent work. Who is that high-pitched voice student that I'm hearing? I don't know. Alright, so pause the video and do this. Alright, hopefully you paused the video, and now you've done the work, and you're going to check your work with me right now. So I've got Q prime, R prime, and S prime. I'm going to calculate where all these points are, and then I'll plot them. So 0 times 1/3 is 0. Now I need 6 times 1/3. Now 6 over 1 times 1 over 3 equals 6 over 3, which is 2. Alright, so 6 divided by 3 is 2, so I've got 6 times 1/3 is 2. Now for R, it's the same thing, but this time it's -6, so I'll end up with -2. And now 3 times 1/3, so 1/3 of 3 is 1, and it's negative, so it's going to be -1 here for R, for the Y value of R. Now for S, 6 divided by 3 again is 2, or 6 times 1/3, same thing, is 2. And then -3 times 1/3, so 1/3 of -3 is -1. So these should be the points that you have. Q is 0, 2, R is -2, -1, S is 2, -1. Let's plot these. Q is 0, 2, Q prime, -2, -1, -2, -1 for R prime, and then S prime is 2, -1. And then there is my new triangle, my image. My pre-image is much larger, my image is smaller. That's how I know I have a reduction. Also, my scale factor is less than 1. Notice that in both of these examples, the shape remains exactly the same, except for it's a smaller or larger version of the original. So every time you do a dilation, make sure that your pre-image and your image look exactly the same, except for one is smaller than the other one. If they get skewed in a different way so that they're not quite the same shape anymore, you know you've done something wrong. Let's do one more dilation. And let's make this another U-try. All right, okay. So D is going to be 4, 4. F is 0, 0. G is 8, 0. And we want the dilation, your scale factor is going to be 0.75. Okay, So let's plot these points here. So D is 4, 4. G is 8, 0. And F is 0, 0. So here is my pre-image. Another triangle. So many triangles. Okay. Now this is going to be U try. So multiply each of these by 0.75 to get your new points. Plot those. And then play the video again. So pause now. And welcome back. I hope you are confident with your answers here. So let's find D prime, F prime, and G prime. All right, D. So 0.75 times 4 is 3. 0.75 times 4 is 3. And you can do that by saying 4 over 1 times 3 over 4, that's 0.75, right? Equals 3. All right. You could say 4 times 3 is 12, 1 times 4 is 4, 12 divided by 4 is 3. However that works in your mind, that's how we get 3. 0 times 0.75 is 0. 0 times 0.75 again is 0. 8 times 0.75 is 6. 0 times 0.75 is 0. So hopefully those are the points that you got. Now let's plot these. 3, 3 is right here. That'll give me D prime. 0, 0 again is right there. That was my F and my F prime. And then G is 6, 0, or G prime is 6, 0. So let's connect these. And there we have a reduction. 0.75, less than 1. Here's my image. Here's my pre-image, sorry. Here's my image. We have a reduction. There it is. That last example that's on your notes here is a reflection and rotation deal from the last one. So you can do that one if you want. Take a look at it, but I'm not going to do it here on the video. All right, hope you're doing well. Good luck on the homework. See you soon, maybe, hopefully. All right.